In the previous lesson, you learned how to multiply two binomials together, usually resulting in a trinomial. In this lesson, you're going to learn to do the opposite, and that's called factoring. Factoring will prove useful in many situations, but in particular solving equations and graphing. So the first thing we're going to look at is how you can use factoring to solve a quadratic equation. So far, the only way you would be able to solve the quadratic equation here is by graphing it. But here's the way you can figure it out without graphing. We're going to do the opposite of FOIL. So I'm trying to find two binomials that would multiply together to give x squared plus 4x minus 5. So I start by looking at the x squared, and I ask myself, what has to go in each of the two first positions so that when you multiply them together you get x squared? And in this case, the only real possibility is x times x. Next, I look at the negative 5, and I need two numbers that multiply together to make negative 5. Well, clearly, 5 times 1 is the only way to get 5, and lastly, I have to check that the inner and outer products combine to give you 4x. So if you think about it, if I put a plus sign here and a minus sign here, then the inner product is positive 5x, the outer product is negative 1x, and those do indeed combine to give you 4x. So what I've done is FOIL, but in reverse. So let me now erase this, because that's going to be in the way for the next step. But you can look at that again and verify on your own that if you FOIL these together, you will get x squared plus 4x minus 5. Okay, now that it's written as factors, you have to think about it this way. There's two things we're multiplying together, x plus 5 and x minus 1. And when we multiply them together, we get 0. If you think about it, the only way that that can happen is if one or the other of the factors is 0. So one possible way of getting 0 would be for x plus 5 to be equal to 0, in which case x would be negative 5. And then the other way you might get 0 is if x minus 1 is 0, which leads to the solution x equals 1. I'm going to show you that 1 solves this equation by plugging it in. If you do 1 squared plus 4 times 1 minus 5, well, that's 1 plus 4 minus 5, or 5 minus 5, which is indeed 0. I leave it to you to check the negative. Actually, you know what? I'll go ahead and check the negative 5 also. If you square negative 5 and then add 4 times negative 5 and then subtract 5, well, remember when you square negative 5, negative times negative is positive, and then 4 times negative 5 is negative 20. And again, if you add the first two, that's 5 minus 5, and again, we get 0. Okay, so let's look at another example. This one, before you even attempt factoring, you really want to make sure it's equal to 0. So I'm going to subtract 16 from both sides, because factoring won't help you solve an equation unless it's equal to 0. So this is the part that you might really need to practice, is actually factoring. Well, again, in order to get x squared, it's got to be x and x. Now, to get negative 16, I'm just going to think about 16. I could multiply 1 times 16. It might be 4 times 4. It might be 8 times 2. And you just have to play around with the numbers until you find a combination that works. I'm going to put an 8 and a 2. And if I make this negative 8 and this positive 2, well, then my inner negative 8x and my outer positive 2x if you add those together, you do indeed get negative 6x. So that's the correct factoring. Let me clear that out of the way so I can continue with the solution. And then if the product of two factors is 0, well, either x minus 8 is 0, or maybe the x plus 2 is 0, leading to x equals 8 or x equals negative 2. Okay, one more example. Again, don't even bother factoring until you subtract 7y from both sides so that it's equal to 0. And then this one, factoring is a little different. I'm just going to show you what it looks like when you factor it. If you were to apply the distributive property, y times y is y squared, and y times 7 is 7y. So it looks a little different, but it's the same idea here. And then if the two things multiply together to make 0, either the first one is 0 or the second one is 0. Y equals 0 is already solution. Add 7 to both sides and I get two solutions there. Okay, let's move on to how you can use factoring to help you understand the graph of a quadratic. Well, this is written in vertex form. Oops, there's a mistake here. Let's cross that out. The vertex should actually be 1 comma negative 4. Sorry about that. And I'm going to show you how you could rewrite this quadratic function in what we call factored form. So the first thing I'm going to do is FOIL together x minus 1 squared. I'll write it out twice. That might help. And then x times x is x squared. The inner and outer products are both negative 1x, so I get minus 2x. And then negative 1 times negative 1 is positive 1. And then I still have a minus 4. Now I'm going to combine my like terms, in this case positive 1 and negative 4. And then I'm going to factor x squared minus 2x minus 3. Okay, so it's going to be x and x. It's got to be 3 and 1. That's the only way to get 3. And if I make the 3 negative and the 1 positive, then you see the inner negative 3x and the outer positive 1x would indeed combine to give you negative 2x. So I've just now written it in what we call factored form. I'll show you on the next screen why that's useful. Alright, so vertex form lets us know that the vertex is 1, negative 4. So I'll graph that 1, 1, 2, 3, 4. Factored form gives us what we call the roots, R1 and R2, of our function. And what that means, I'll show you. Suppose you plug in a 3 for x. Well, the first factor evaluates to 0, and then it wouldn't even really matter what the second one was, because 0 times anything is 0. So when x is 3, 1, 2, 3, y is 0. Similarly, if you plug in a negative 1 for x, negative 1 minus 3 times negative 1 plus 1, well, this negative 4 doesn't even matter because the second factor becomes 0, and that's 0. So when x is negative 1, y is 0. And you know that every quadratic function should create a parabola when graphed. So there you have it. So these points, negative 1 and positive 3, are called the roots. And you'll notice that when the root is negative, the factor is plus 1. And when the root was positive 3, the factor was actually minus 3. Okay. For your homework, I just want you to practice factoring. You're not going to solve equations. You're not going to graph things. I just want you to practice the skill of taking a trinomial and deconstructing it into two binomials. So this is the FOIL process in reverse. And it's kind of a skill that's useful and it requires a lot of practice. So there's 4 problems here. Take the time you need to rewrite each one as a FOIL problem. And then, of course, use FOIL to check and make sure that it works. Okay.